Behold the picturesque lake, a source of inspiration and home to many living things. Ah, it's a model of tranquility. But is it really? Are there mysteries that lie beneath the lake's placid surface? Local stories abound of a rarely seen creature that resides deep, deep down under the water. Yes, it is the legend of...
What?
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Pond Scum, making oxygen for over 3 billion years.
Now available in extra light green.
You and I are animals that need water. We love it. We're practically made of it. Now, wherever you are, if you want to find water, go up and look low. Because low places are where water collects. We call these places lakes and ponds. See, water's no different from you and me. It gets pulled down by gravity. So wherever there's a depression or low basin in the land, and there's enough water around, water will form pools. Sometimes the pools get pretty big. To make a lake, we need a depression, a big basin, a swale, a dip. We need a mushed-in part of the earth. So, gravity pulls glaciers downhill. Then it fills up, forming a lake. Earthquakes can slough off huge chunks of land, leaving a basin that fills up to form a lake. Meteorites can make big holes. The crater fills up and forms a lake. Since it's not hard to figure out which way water will flow, humans can change and even make our own lakes and ponds. And since they're full of water, lakes and ponds have fabulous ecosystems like we don't find anywhere else. Lakes and ponds are wild. They're wild. They're wonderful. They're places where we land animals love to go to get a drink.
Let's say you find yourself in the middle of a body of water surrounded by land. Ask yourself, is this a lake or a pond? Well, lake.
Lake comes from the Greek word lak, meaning hole, and pond comes from the Middle English pund, meaning enclosure. With that said,
Is this a lake or a pond? Well, ponds are generally smaller and shallower than lakes. So shallow, in fact, that sunlight can reach the bottom, even in the middle. That way, plants like these water lilies grow all over the place, in a pond.
Science rules. Science rules.
Lakes, on the other,
lakes are usually bigger and deeper than ponds, and they're places where the sun don't shine, underwater. So the plants grow along the edge or shoreline. But both ponds and lakes are just loaded with life. There's fish and flies and...
frogs. Ribbit.
Science! Lakes and ponds are by
When it rains 5 centimeters, it rains 5 centimeters all over. See, here's 5 centimeters of water right here. It doesn't look like much, but it really adds up. See, here's 5 centimeters in this big container. It's a lot bigger, has a lot bigger surface area, so there's a lot more water. Well, suppose you put 5 centimeters of water in an even bigger container, like one the size of this lake. Well, 5 centimeters of water in this lake is over 100,000 tons of water. So why doesn't the lake just overflow every time it rains? Well, there's a small stream at the other end, which is draining some of the water out, but not nearly enough to keep the lake from just filling and filling. Well, it turns out that the energy from the sun makes the water in the lake evaporate, turn into a vapor. It's the equivalent of over 1 million hair dryers running all day.
1 million hair dryers!
Well, it's a lot of heat. It's a lot of water. It's a lake, for crying out loud.
But all the rain that falls upon the land does not stay on the surface or even in the topsoil. Water from melting ice and snow and from the rain seep down through the soil, through a maze of cracks and fissures in the rock formation.
Not all the water that goes into a lake is water that you can see. Please consider the following. Take a look at this. It's our great big groundwater flow model of science. Well, it's not that big. And let me put some ink in here so you can see the flow of water underground. Now I'll turn on the rain. Let's say that this little puddle is a lake, Lake Little Puddle. It's filling up with water that's flowing over the ground from rain, rivers and streams. But it's also filling up with water that goes underground.
Just as streams on the surface of the land grow as they are fed by rain and tributaries, so do underground streams grow as they flow along.
As this part of the soil fills with water, the water flows this way and soaks right through the lake bottom, filling it up. Not only does the water flow this way, it also goes down. It flows through different layers of rocks and soil. Now, as the water flows through different levels of different densities, it often changes direction. Wherever the level of the water ends up, we call that the water table. And the rocks and soil that are holding the water, we call the aquifer. It's from old words that mean water carrier. When the water table's high, lakes fill up a little bit. When the water table's low and the ground is dry, lakes leak. See, a lot of the water that ends up in lakes and ponds comes from underground. It's groundwater. Well, thank you for joining me on Consider the Following. To clean this up, I guess.
Discover the pure goodness of authentic Basin freshwater. When it's fresh water you want, drink Basin freshwater.
Where does water in lakes and ponds come from? Rain, rivers, waterfalls. But it also comes from underground aquifers. Water flows through soil right under our feet, which is why you can be polluting a lake even if you're kilometers away from the lake itself. Pesticides that farmers use in their crops can soak into groundwater and get carried into lakes and ponds. Cars make pollution. Dogs make pollution too. Look, water runs downhill. So if you fertilize your lawn, that's fine for your lawn. But eventually, some rain's going to fall. And when it does, some of that fertilizer is going to get washed into a lake. Fertilizer's okay for your lawn. Well, too much fertilizer can kill life in a lake. A little pollution spread out over the land doesn't stay spread out. No. It ends up here. See, it affects all the living things in the lake ecosystem. So when you see the lake getting polluted, it means the area around the lake is getting polluted too.
I'm Andrea Leslie, and I'm a freshwater ecologist. Lakes and ponds are affected by air pollution through acid rain from cars and industry, and we measure these effects. Even here at Mount Rainier National Park, which is a very wild and pristine area. To study ponds and lakes, people take samples of water and look at water chemistry. They look at how the soil in the pond is formed, whether it's sandy or silty. And they look at animals such as invertebrates and salamanders and fish, as well as plants and algae.
This looks like a bunch of sticks, but it's actually the house of a little insect called a caddisfly.
An insect community or an other invertebrate community can reflect how healthy a pond or a lake ecosystem is. frogs and salamanders are good indications of what the health is of the whole environment. So if we've got declining amphibian populations, we might have to worry about ourselves because the environment is changing around us. Lakes and ponds are really special ecosystems.
This may seem like just a jar of pond water, but it's more than that. It holds the key to all pond life. It's full of microscopic plants and animals that help provide food for every living creature in the pond. Don't believe me?
No, I don't.
Well, look. Take a clump of algae,
Right.
put it on a slide, put some pond water on there.
Naturally.
See that straight stuff? That's algae. Algae are single-celled plants that take energy from the sun and make food and oxygen. Tiny creatures like these protozoa eat the algae, which get eaten by tiny fish, freshwater clams, and insect larvae, which are then eaten by bigger fish, turtles, birds, and other animals in and around the pond or lake. So you see, algae is the key, and it's smaller than you can see.
Even a single drop of pond water revealed forms of life never before seen. Tiny, one-celled animals and plants.
Life. See this? It's salt. This is the Great Salt Lake. What's so great about the Great Salt Lake? 2 million tons of water flow into the lake every year, and no water drains out. What could be greater than that? It works like this. Water carries minerals like salt into the lake, and since there are no rivers or streams to carry the salt away to the ocean, the lake stays salty. It's the Great Salt Lake. That's pretty great.
Now, here are some of the inhabitants of the freshwater pond.
Pond and lake life is layered. Some plants and animals, like these whirligig beetles and water striders, live on the surface. A lot of the times, they never even get wet. Below the surface, tiny plants and animals called plankton can be found in every part of the water where sunlight reaches. Below that, it's dark and cold, and there isn't a lot of food. So bigger animals that can move around, like fish, giant water bugs, or tadpoles, live here and come up into the food-rich top layer, while crayfish, leeches, clams, and certain insect larvae live in the mucky bottom. The mucky bottom.
There are many species down there, but
it's one lake, but it's made up of different worlds.
This beaver is as busy as a beaver making his home. But he's making more than that. He's also making a dam that will stop the flow of water and turn an ordinary stream into an extraordinary ecosystem called a pond.
Here! Over here!
Bill?
Right here!
Where are you?
It's Bill! Hi! The science guy, up here!
Where the heck are you, Bill?
Back the other way!
I can't see you.
Yeah,
Bill?
up here!
Where?
Where? Right here! Huh? See, when humans dam up a river,
there you
we
are.
often create a lake. This is Grand Coulee Dam. And behind it is Lake Roosevelt. It's a pretty young lake, really, only about 50 years old. See, before the dam was built, the Columbia River flowed right through this valley. Then when the dam went in, the flow of the river was blocked, and a lake formed. It turned the river bed into a lake basin. Now, Roosevelt Lake, Lake Roosevelt, is a big lake. Big! It's huge. I mean, it's really big. Big! It's gigantic. It's enormous. It's huge. It's 100,000 soccer fields put together. Big!
100,000?
That's right. 100,000 soccer fields big. And we built it. We humans. Now, when we do something like this, it's not without costs. I mean, people who lived near the old riverbank had to move. But in return, we all get electricity, water for irrigation, and of course, recreation.
Rowing, skating, sailing, diving, water sitting.
Ever heard of the Great Lakes?
yes, these are the truly Great Lakes.
There are 5 of them. Huron, Ontario, Michigan, Erie, Superior. They're pretty easy to remember. Holmes, not bad. Now, the Great Lakes are big.
Largest of all chains of inland seas.
You can't see from one side to the other. They're so big.
They and their connecting locks and waterways extend from the prairie lands of Minnesota and the head springs of the Mississippi, eastward 2,000 miles to the tidal mouth of the St. Lawrence.
But there's another lake that's bigger than all of the Great Lakes put together. Lake Baikal in Siberia is over 1,700 meters deep. It's huge. It has more water than all of the Great Lakes combined. It's huge. It's enormous. To get to Lake Baikal, you just go to Ulaanbaatar and head north to get to Ulan-Ude and hang a left. Can't miss it. Oh, if you end up in Usaliye-Sirskoye, you've gone too far. Lakes and ponds are bodies of water surrounded by what?
Cut. Hey, Bill. No, the other way. Hey, come here, please. We need you. Hurry up, come on. Now, lakes and ponds are bodies of water surrounded by what? Land, on all sides. How do they form? I'll tell you how. 6, count them, 6 ways how lakes and ponds form. First, glaciers kind of carve a basin. Second, earthquakes or volcanoes make a hole. Third, twisty rivers sometimes get pinched off. These lakes are called oxbow lakes. Pretty cool, huh? Fourth, beavers. I mean, these critters build dams in streams or rivers which make them overflow into a lake or a pond. Now, fifth, people. We build dams and create lakes and ponds. We use the water for livestock, power, or recreation.
Look out, Grandma!
Now, 6. This is the good one, all right? Meteors. Blammo! Cruising in from outer space, huh? Not that bad, huh? Any questions?
Hey, Chase! Chase!
I'm floating on a lake, or maybe it's a pond, I'm a mighty fond of the lakes and ponds. I'm a mighty fond of the lakes and ponds. Taking a look around, cause the animals all abound in the water, on the shore, in the mud down below. Hey!
AKA ponds.
The plants living in the water, living in the shoreline. The water, living in the shore.
Life.
I'm a mighty fond of the lakes and ponds.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some aphotic zone mixing pressure delta vanes to calibrate. See ya!
Produced in association with the National Science Foundation.
Ah, beautiful! Yeah, the pressure vanes are okay. I gotta look at them. Well, no, I mean, I didn't make enough time to pack all yesterday. Oh, hold on, here's one right here. Hang on a second. Hang on. I can't see it. Okay, hang on. For smaller animals and plants, the surface of the water is like a floor because of surface tension. But for us larger animals, with some other water solution, or even wacky, kooky, we could use less water. I myself personally have got to stop because we're so far off the script. I would rather not live in a world without legs.